Hello, and welcome to my Excel report. I'm just going to take you scenario by scenario, sheet by sheet, and explain. So I have a relatively small laptop screen, so there's going to be a lot of scrolling and zooming here. This is my cover sheet. Scenario one, relativity and number density. We use scientific notation to determine the different sizes relative to each other. So my first one I have here is a Tyrannosaurus Rex, and we used what's called the E plus and E minus formula, which E plus and E minus stands for 10 to the power of. So in this case here, the Tyrannosaurus Rex is 7 meters times 10 to the power of 0, so E comes out to 7. Now as opposed to the blue whale, which is 3 times 10 to the 1 power of 1 meters, that comes out to 3 times 10, which is 30. So you can see there, the relative size. The Tyrannosaurus rex is much smaller than the blue whale. This dinosaur, whose name I will not even attempt to pronounce, he or she is 6 times 10 to the 1 meters, so it makes him 60 meters. And you can see this first number here has no real determination on how big they are, because this is a 7, this is a 6, and this is the smallest, and this is the biggest out of the three. But it has to do everything with that exponent there. Another thing that we looked at was the speed of the body movements around us. So we put together a pie chart to showcase the data that we have here, as well as a bar graph and one for scientific notation as well. And the E in the scientific notation is just a way to shorten extremely long numbers. So when you have an extremely long number, the amount of zeros that you have in that number is relative to the exponent after that 10 to the power of 5. So all mine are positives. You also have negative, which is the E minus. That would be for things that are less than 1. So if you had something that was 6 times 10 to the negative 1 meters, then it would be 0.6. And then for each exponent that you put on, you add a 0 before the number after the decimals. So 6 times 10 to the negative 2 would be 0.06, and so on from there. The next scenario we did, scenario 2, dealt with misleading data. And it just goes over charts that, graphs and charts that show certain data and how it can be misleading. The first one we have is unemployment rate in the Clinton years versus the Bush years. And you can see here on the chart that 5.2052 for the unemployment rate for Clinton years and 5.1852 for Bush years, which is only a 0.02 difference between the two. The way that the information was given to us on the chart was starting out at 5.175, and it only goes up by intervals of 5 here, or 0.05, sorry. So you can see 0.175, 0.18, 0.185, 0.19, and doing that, giving it very small intervals going up, makes the graph look extremely different there. Now, if you were to start both of them at 0 and going up in bigger intervals than just these little minute numbers here, so 1, 2, 3, 4 whole numbers here, you can see that right here between 5 and 6, you have both the unemployment rates for Clinton years and Bush years, and there's hardly any difference. That's where you can really see that 0.02. We did the same thing for bowling averages for a group of friends here. You can just see that there's a huge difference here. We start at 105, we're going up by 5. Here, we're going up by 20, but it's right here in between the 100 and 140, right around that 120 line. You can see 120, 114, 126, really close. Then we did the percentage here. We were looking at this graph and we had to recreate this to see if they were telling us the truth, if Cartera was really 4.5% of the entire circle. And we just recreated the circle here, the bigger one and the smaller one. As you can see, we did the relative size there. And what you have to do first is you find the area of the circle. So you take the diameter, and you can see our formula here. So you do pi times the diameter. Here's the diameter of the big circle, 2.39. And you do pi times the half, 0.5 of the diameter. And that gives you the radius. And you take that number and you square it. And so we got that number here, and then the area of the smaller circle is here by using that same formula. And then what you do to get the percent of the smaller circle from the bigger circle is you take the smaller circle number, divide it by the bigger number. Here's our formula, and you can see that it's actually 14% of the bigger circle, not 4.5%. And then we did very similar thing, just looking at the way that it's misleading in the chart here for arena funding. And you can see the city, it says 265 million when really, and it looks like half the entire circle when really it takes the place of a great majority of the circle, almost 3/4 of the circle, 65%. And you can just see the differences there. Unknown 2%. Looks like it's about same here as the AEG, which you can see it's clearly not. Scenario 3 was a little bit longer, and we were going over American population and finding out the population with obesity, type 2 diabetes, and high blood pressure, all three individually, and paired them up. You can see here we did a chart that showcases the American population in full, and then we were given the information for all the percentages, and we had to find the number in millions. And the way we did that was taking the percentage and we multiplied it by the American population in full, and it gave us that number. We did it all the way down. And over here you can see this is type 2 diabetes, obesity, high blood pressure. That little loop, that's type 2 and obesity, type 2 diabetes, and high blood pressure. And this one here has all three. Once we got those numbers, we were able to figure out in Venn sections, because we were doing a Venn diagram, and calculate the totals of everything. So all we did first was we had to work backwards, and we got the total amount for all three, which we got from here. And then we worked up. So we did obesity and high blood pressure here minus the number for all of them. We got that, and we worked that all the way up. We found the percentages of everything. You can see our formulas here. And then we showcased this information in Venn diagrams. So first we did the millions. So we did whole numbers, 207.7 million Americans with none of those diseases. They go on the outside. Obesity, 10.2, high blood pressure, type 2 diabetes. Took the percentages, 63.1 is the same exact info, just in percentages. Obesity, high blood pressure, type 2 diabetes. And then just some information about American population, obesity, diabetes, hypertension. For Texas, actually. This is for Texas. Scenario 4 focused on measures of center and distribution, and lots of formulas go into making this, but basically it's centered around two separate sets of data, BMIs for Army recruits and then BMIs for random mall shoppers. We can kind of determine just based off of the titles there that Army recruits BMIs are going to be very similar because they have very similar body types, muscular or athletic, as opposed to random mall shoppers. You're going to have various types of mall shoppers, tall, short, children, elderly, young adult, fit, not fit. So you have a lot of data there that's going to be taken into consideration. Then we have our trend lines here, which shows that all the obesities of the Army soldiers are right around the trend line as opposed to here. And, you know, there's a little bit more scattered on our plot, our scatter chart here. And then you have this guy, that one at 72.5. That one right there is called our outlier, and it's basically the data set that's just like way off to the side. It has, you know, no correlation to the rest of this here. It's just way out there. And really what that does in the long run is it skews our data, and we're not able to use this anymore because it's just none of our averages are going to come out. Their coefficient of variation is going to come out way skewed because of this number. But we're able to find the range, median, mean of this information, which is all relatively close. The range is basically just the highest BMI minus the lowest BMI. That gives you the range. The median is the exact middle. So when you order these from greatest to lowest or lowest to highest, whatever is right in the middle. So we have an odd number here, so we will have a single median. The mean is the average of all these. And you find the standard of deviation and the coefficient of variation. The coefficient of variation is just going to be the standard of deviation divided by the mean. So we took that information and we put it here in descending order. And we found our median. And we were able to put together our charts here and find the BMIs here on this scatter plot using the information that we've gathered. Scenario 5 focused on investment, sales, and profits. So we did a scatter plot here. This shows that with our sales 0 through 100, and the profit that we would make. The profit equals X equals 500X. So basically 500 times B9. B9 would be our amount of sales, and that's X. So went all the way down. You can see that it goes up. Profit, we continuously make a profit. And the example that we were given was Elon Musk and his sales of flamethrowers. And when he first started at zero sales, he had a negative $12,000 profit. And most likely because he had to spend money to make money. And you can see for the first 100 sales, he just continued to lose money until finally, right there at about 100 sales, that's the lowest point of his sales, he started finally rising and making money. And just after 200 sales, he finally hit that zero mark where he started making a profit. And you can see we're at 3,500 here. So probably at about 205, 202, 205, he started making it. He crossed over that zero line. He's making profit. One of the questions asked about a $90,000 profit, and it looks like he sold somewhere between 240 and 260 to make 90,000. It looks like it's probably about 255-ish that he made that 90,000 mark. And then the sales go up to 300 here. So you can see at 300 sales, he made 187,000, which is going to be right around in here. But 300 sales, and then that's going to be the highest point that we recorded. Then we went ahead and started calculating his interest and his investments using these formulas here. We found the simple, annual, compound, and continuous compound interest. P being the principal invested, which we started out at 5,000 for all of them. The annual compound one here is going to be the number of times it's compounded per year. So that value never changes. The principal invested never changes. And the interest rate never changes. It's always going to be 6.0%. And the way to do that is to put dollar signs around the letter for the parts of the formula that won't change. So that way when you do this first formula, you calculate it, you can copy it all the way down, and those values will not change. The only thing that changes is the number of years. And then we put that together in a scatter plot here that shows all three. And lastly, the one that gave us the most research, our 5-year financial plan. So this is, hypothetically speaking, where we would want to be in 5 years. There's a bunch of different activities that we did before we went through all the financial portion of everything. So we did an activity chart here, and I plan to only work 40 hours a week. As a teacher, you go in a certain time, you can leave at a certain time. There's not a whole lot of factors that make you stay much later than that. You have your parent-teacher nights or occasional meetings, but I don't plan to do much more than 40 hours. And just kind of calculating the different amount of hours for each week. And this is a 168-hour week, 7 days, 24 hours a day. And put all that together in a pie chart so you can kind of see 24% of my entire week I'm spent at work, and 17% I'm eating. So just different things there. Nutrition-wise, I plan to be a healthy eater. Don't know how well that's going to work out. But just certain things here: wild-caught seafood, grass-fed, pasture-raised dairy, leafy greens, fruits, nuts, stuff like that. My servings per week, and just put that together. It's very similar to the activity chart here. So we just put all that together in there, pie chart, some snippings of some of those foods. And then we get into the financial portion of everything. So we had to come up with the salary. So I plan to become a teacher. I plan to get my teaching degree. And in Texas, based off of what you teach and where you teach, they have different starting points for salaries. First year is roughly going to be $4,900. My wife is also a teacher. She's special education. So she's going to be making somewhere close to what I'm making, but she's going to be further up in her career. And then I also do delivery service, so Favor or Amazon Flex on the side just for extra cash. Vacation money, spending stuff. And then taxes. Texas doesn't do a state tax. They only have the federal taxes. And based on the income that we'll be at, we're going to be at a 22% tax bracket. So we'll just have to calculate the taxes based off of that. And doing so, I get the annual income here. Now we get monthly expenses, and there's going to be everything from gas to internet, utilities, clothes, entertainment, household repairs, medical, dental, insurance, huge, um, stuff like that. And factored into that is going to be a car payment and mortgage. So I would like to have a house here in Hutto. It looks like something that we can afford. There's a $229,000 home. It's 4 bedrooms, 3 baths, 1 story, almost 2,200 square feet. And using a mortgage calculator, put in the total amount here, no down payment because I don't think we're going to have any money to put a down payment. And a 4.75 interest rate calculates roughly about $1,194 for the mortgage. I rounded that to $1,200, so $6 difference. Better to round up than down. Car payment looks like a Mitsubishi Outlander. I currently have that vehicle, so I don't plan on getting rid of that in the next 5 years. But I factored in $450 just for the payment and the insurance and all the good stuff that goes with that. So this kind of just rough estimate there. And then this is I'm pretending that's me, but this is going to be the classroom teaching elementary school. And then, just based off of this information here for our monthly expenses, putting that into a pie chart, you can see the percentage of everything that's being spent, as well as a bar graph, and you can really see what's being spent here. So your mortgage takes up quite a bit. Taxes are going to be huge. Then medical and dental, you can see that compared to like your entertainment, crazy. And then I was able to come up using the annual income. I divided that by 12 to get the monthly income. Monthly expenses were calculated adding all this up here. And you can see the formulas there and the difference. So this is going to be what I have left over every month, roughly. And then income versus expenses. So annual income versus annual expenses. I took this number and multiplied it by 12, and I got this number here. Well, there you have it. That's my Excel report in a nutshell. That's going to be everything that we've learned up to this point, and I look forward to doing more in the future. Thanks.